Hey, my name is David Florian. I'm a fourth year student in the Guelcher Lab, and historically the Guelcher Lab has focused on fracture healing through using bone resorbable cements as well as drug-eluting biomaterials. If you're interested in this research, you can definitely check out Dr. Guelcher's past publications, but in today's video I want to talk about future directions this lab is heading in that you can't find on Google Scholar. I also will take the opportunity to talk about the work-life balance of the Guelcher Lab as well as the culture that we've created here. As you know, bones provide structural support, but they also play an important role in hematopoiesis, which gives rise to all the red and white blood cells in your body. To take you through a day in the Guelcher Lab, we're going to build a bone marrow on a chip model, which exemplifies our foray into biofabrication and rapid prototyping. The first thing we need to do is print a mold on our SLA printer. Now this can take a little while, but once it's done, we have a high fidelity mold which we can fill with PDMS. We will then vacuum out the bubbles and cure it in the oven. After a couple hours, we'll have this single channel microfluidic device. Now in this deep channel, we'll stick our polyurethane and ceramic foam, which not only mimics the mechanical properties, but also the chemical properties of trabecular bone. If you look really close at the scaffold within the chamber, the porosity of it looks like spongy bone, and that architecture is exactly what we're going for. Now for the next step, we need to seed patient cells on the scaffold. We're going to head over to the medical center where Dr. Guelcher also has lab space to meet up with Taylor, another grad student. So Taylor's in the cell culture hood right now. Hey Taylor, how's it going?
Hey, I'm Taylor. I'm a second year grad student, and a lot of my day-to-day work involves the cell culture for our bone marrow on a chip model. So here I'm working with some healthy and diseased hematopoietic stem cells, and one of the main benefits of culturing them in our microfluidic devices is it allows for easy access for microscopic imaging so that we can look at the differences between those two states.
In addition to our polyurethane foams, we also 3D print via inkjet printing trabecular scaffolds from micro-CT scans of human bone. With these models, we implant them into mice for long-term observation of hematological stem cells near the bone interface. I hope you enjoyed this brief look at just a couple of the projects the Guelcher Lab has underway. I want to finish up this video by talking about work-life balance in our lab culture. The Guelcher Lab self-selects for highly motivated and independent researchers. Our lab promotes innovation, and Dr. Guelcher's track record of protecting his students' IP through patents allows you to go down the entrepreneurial route if you so choose. Perhaps my favorite part about the Guelcher Lab is how grad students and undergrads work together without being competitive, because let's face it, grad school is stressful enough. Before the pandemic, happy hours and hangouts were the ultimate de-stressors for the Guelcher Lab. We look forward to seeing you on campus.